NEC 1999 requires grounding of snap switches in non-metallic boxes only if the switch or box is not located within 6 feet of an accessible grounded 3-wire receptacle. NEC 1999 and NEC 2002 do not specifically address the grounding of 3/4-way switches. However, most 3/4-way switches do not have a ground screw, making it difficult to ground them directly. If the 3/4-way switches are located within 6 feet of a grounded 3-wire receptacle, grounding is not required. If the switches are located more than 6 feet from a grounded receptacle, they should be mounted in grounded metal boxes, or an isolated ground conductor should be run to the switch location. Alternatively, a bonding jumper can be installed between the switch box and a nearby grounded surface, for example, a grounded metal conduit. It is always best to follow the latest edition of the NEC for the most up-to-date requirements. Now let's delve deeper into the nuances of grounding snap switches and 3/4-way switches according to the NEC, focusing particularly on the 1999 edition and drawing comparisons to later editions where relevant. The National Electrical Code, or NEC, serves as the cornerstone for safe electrical installations. Understanding its requirements is crucial for electricians, electrical engineers, and anyone involved in electrical work. Grounding, a fundamental safety practice, plays a vital role in preventing electrical shock and minimizing the risk of fire. When discussing grounding requirements for snap switches in non-metallic boxes under NEC 1999, it's essential to recognize the specific condition that triggers the need for grounding. According to the NEC 1999, grounding is mandated only if the switch or the non-metallic box housing it is not situated within 6 feet of an accessible grounded 3-wire receptacle. This 6-foot proximity rule is a key element in understanding the code's intent. The rationale behind this rule is that if a grounded receptacle is nearby, it provides an alternative path for fault current to flow back to the source, thus reducing the potential for dangerous voltage buildup on the switch or box. When a fault occurs, the current will preferentially flow through the grounding path, tripping the circuit breaker or fuse and energizing the circuit. This mechanism significantly reduces the risk of electrical shock to anyone who might come into contact with the faulty equipment. Now, let's shift our focus to 3/4-way switches. These switches, commonly used in residential and commercial settings to control a light from multiple locations, present a unique challenge when it comes to grounding. As noted, NEC 1999 and NEC 2002 do not explicitly address the grounding of 3/4-way switches. This lack of specific guidance can lead to confusion and inconsistent practices in the field. Compounding the issue is the fact that most 3/4-way switches are not manufactured with a dedicated ground screw. This omission makes it difficult, if not impossible, to directly connect a grounding conductor to the switch. In light of these challenges, it's crucial to adopt best practices and adhere to general grounding principles to ensure safety. Several approaches can be taken to address the grounding of 3/4-way switches. Firstly, consider the 6-foot proximity rule mentioned earlier. If the 3/4-way switches are located within 6 feet of a grounded 3-wire receptacle, the NEC 1999 does not require additional grounding measures. However, if the switches are located more than 6 feet from a grounded receptacle, further action is necessary to ensure a safe installation. One recommended approach is to mount the 3/4-way switches in grounded metal boxes. Metal boxes, when properly grounded, provide a robust grounding path for any devices installed within them. To achieve this, ensure that the metal box is connected to the equipment grounding conductor, which is typically a bare or green insulated wire that runs back to the service panel. The connection between the metal box and the equipment grounding conductor should be made using approved methods, such as a grounding screw or a grounding clip. Another option is to run an isolated ground conductor to the switch location. This involves pulling a separate grounding wire from the service panel or a nearby grounding point to the switch box. The isolated ground conductor provides a dedicated grounding path for the switches, independent of the building's wiring system. This approach can be particularly beneficial in sensitive electronic circuits where minimizing electrical noise is critical. A third alternative is to install a bonding jumper between the switch box and a nearby grounded surface. This involves connecting a wire, known as a bonding jumper, between the metal switch box and a nearby grounded element, such as a grounded metal conduit or a metal water pipe. The bonding jumper creates an electrical connection between the two surfaces, ensuring that they are at the same electrical potential. This helps to minimize the risk of voltage differences and potential electrical shock. It is important to emphasize that any grounding or bonding connections must be made using approved methods and materials. This includes using the correct size of wire, proper connectors, and ensuring that all connections are tight and secure. Loose or corroded connections can compromise the effectiveness of the grounding system and increase the risk of electrical hazards. While the NEC 1999 provides a specific rule for snap switches in non-metallic boxes and lacks explicit guidance for 3/4-way switches, it's crucial to consider the broader context of the code and the underlying principles of electrical safety. Grounding is not merely a code requirement, it's a fundamental safety practice designed to protect people and property from electrical hazards. Therefore, even in situations where the code is not explicit, it's always prudent to err on the side of caution and implement grounding measures that enhance safety. Furthermore, it's essential to stay informed about the latest edition of the NEC. The NEC is updated every 3 years to reflect advancements in technology and address emerging safety concerns. While the NEC 1999 may still be relevant in some jurisdictions, it's always best to follow the most current edition of the code to ensure compliance with the latest requirements and best practices. In addition to the NEC, it's also important to consult local codes and regulations. Local jurisdictions may have additional requirements or interpretations that supplement the NEC. By staying informed about both the NEC and local codes, you can ensure that your electrical installations are safe, compliant, and up to date. To summarize, grounding snap switches in non-metallic boxes under NEC 1999 is required only if the switch or box is not located within 6 feet of an accessible grounded 3-wire receptacle. While the NEC 1999 and NEC 2002 do not specifically address the grounding of 3/4-way switches, it's recommended to mount them in grounded metal boxes, run an isolated ground conductor, or install a bonding jumper to a nearby grounded surface. Always follow the latest edition of the NEC and consult local codes to ensure compliance and safety. Electrical safety is paramount, and a thorough understanding of grounding principles is essential for all electrical work. Remember to prioritize safety in every electrical installation and never hesitate to consult with a qualified electrician or electrical engineer if you have any questions or concerns. By adhering to these principles, you can help to create a safe and reliable electrical system that protects people and property from the hazards of electricity. Now let us further emphasize some details when considering the installation and grounding of these electrical components, beginning with a deeper dive into the 6-foot rule and its implications. The 6-foot rule, as stipulated in NEC 1999 for snap switches in non-metallic boxes, is predicated on the assumption that a nearby grounded receptacle provides a sufficient path for fault current. However, it's important to consider the accessibility and reliability of that receptacle. If the receptacle is frequently obstructed or if its grounding connection is questionable, relying solely on the 6-foot rule may not provide adequate protection. In such cases, it may be prudent to implement additional grounding measures, even if the switch is within the 6-foot radius. Furthermore, it's crucial to ensure that the grounded receptacle is indeed properly grounded. This can be verified using a receptacle tester, which will indicate whether the grounding conductor is properly connected to the grounding electrode system. A faulty or missing grounding connection at the receptacle can render the 6-foot rule ineffective and increase the risk of electrical shock. When dealing with 3/4-way switches, the absence of a dedicated ground screw necessitates creative solutions to ensure proper grounding. As mentioned earlier, mounting the switches in grounded metal boxes is a highly recommended approach. However, it's important to ensure that the metal box is effectively grounded. This involves not only connecting the equipment grounding conductor to the box, but also ensuring that the box is securely mounted to a grounded surface, such as a metal stud or grounded conduit. Loose or improperly mounted metal boxes can compromise the grounding path and reduce the effectiveness of the grounding system. Another factor to consider is the type of wiring method used. If the wiring is run in metal conduit, the conduit itself can serve as a grounding path, provided that it is properly connected to the equipment grounding conductor at the service panel and at each termination point. In such cases, the metal conduit can provide a redundant grounding path for the switches, enhancing safety. However, if the wiring is run in non-metallic conduit such as PVC, the conduit cannot be relied upon for grounding. In these situations, it's essential to run a separate equipment grounding conductor along with the circuit conductors to provide a dedicated grounding path for the switches and other electrical equipment. When installing isolated ground conductors, it's crucial to follow specific guidelines to ensure their effectiveness. Isolated ground conductors should be run directly back to the service panel or a dedicated grounding electrode system, without any intermediate connections to the building's wiring system. This prevents ground loops and minimizes electrical noise, which can be particularly important in sensitive electronic circuits. The isolated ground conductor should be insulated with a green or green with yellow stripe insulation to distinguish it from other circuit conductors. When installing bonding jumpers, it's important to select the correct size of wire and ensure that all connections are tight and secure. The size of the bonding jumper should be based on the size of the circuit conductors, as specified in the NEC. The connections should be made using approved connectors such as compression connectors or exothermic wells to ensure a reliable and long-lasting connection. Furthermore, it's important to protect the bonding jumper from physical damage and corrosion. The bonding jumper should be routed in a manner that minimizes the risk of abrasion, impact, or exposure to corrosive element. If necessary, the bonding jumper should be enclosed in a conduit or other protective enclosure. In addition to these specific recommendations, it's important to follow general best practices for electrical work, such as de-energizing circuits before working on them, using appropriate personal protective equipment, and following all applicable safety procedures. Electrical work can be hazardous, and it's essential to take all necessary precautions to protect yourself and others from electrical shock and other hazards. Remember that the NEC is a complex and comprehensive document, and it's impossible to cover all aspects of grounding in a single discussion. If you have any questions or concerns about grounding, it's always best to consult with a qualified electrician or electrical engineer. They can provide expert guidance and ensure that your electrical installations are safe, compliant, and up to date. Also remember to check with your local electrical inspectors. They can provide clarity to your situation, and if your jurisdiction uses amendments that will override the NEC.